All right, in this lesson, we're looking at solving quadratic equations, and this is kind of the thing that we've been building up to throughout all of Unit 6-7. And this is the reason that we've been doing all of this factoring, is because we can use these factoring techniques that we've been learning to solve quadratic equations. So by the end of this lesson, we want to be able to solve a quadratic equation, and we know quadratic equations look like ax squared plus bx plus c equals 0 by factoring. So to get into kind of some context of what we're doing, we're going to take a few steps back and we're going to look at linear equations that you've been solving for the past few years. So if I have a linear equation like 3x minus 6 equals 0, well, we all know how to solve something like this. I'm going to add 6 to both sides to get 3x equals 6, and then I'm going to divide both sides by 3 to get x equals 2. And that's my solution, a value for x. What is significant about this value of x? Why is this the solution to the equation? Well, because if I take x equals 2 and I sub it into, if I look at like the left side of the equation, 3x minus 6, and I sub in x equals to 2, 3 times 2 minus 6, I get 6 minus 6, and the left side is equal to 0. That's significant because the right side of my equation is 0 as well. So x equals 2 is the value of x that makes the left side equal to the right side. It makes the equation a true statement. It, or we might say it satisfies the equation. X equals 2 satisfies the equation. Because it makes left side equal to right side. All right. Well, here we've got a series of, first off, we've got a series of linear equations here that we want to solve. X minus 3 equals 0, x plus 5 equals 0, 2x minus 4 equals 0. And it shouldn't take you more than a quick glance at these to sort of see what the solution is. My solution here is x equals positive 3, because positive 3 minus 3 equals 0. My solution here is going to be negative 5. Negative 5 plus 5 equals 0. This one might take a little bit more work. I might actually have to do a little bit of algebra here. I'm going to bring the 4 over to the other side, and then I'm going to divide by 2, and I get x equals 2. So we know that these are linear equations because we see the x, and the highest power of x that we have is just a power of 1. The highest exponent is 1. And what we notice about each of these equations is that they have one single solution. So linear equations, there's one solution. Now, down below, we have, these are quadratic equations. Now, they don't look like quadratic equations, but we can take something like x minus 4 times x minus 2, and we can expand using our FOIL rule, and we could write this as x squared minus 6x plus 8 equals 0. So if we did that, we would see that this is indeed a quadratic equation. The highest exponent on x is a 2. Now, we want a value of x that we can sub into the left-hand side here that is going to make the right-hand side, make the left-hand side equal to the right-hand side, so the left-hand side has to equal to 0. And if we look at this for a little bit, one possible number that we can sub in is x equals positive 4. Because if I sub in positive 4, what am I going to get? I'm going to get 4 minus 4 in that first bracket times x minus 2. Well, actually 4 minus 2. Which is going to be 0 times 4 minus 2 is 2, which is just going to be 0. So x equals positive 4 is definitely a solution to this equation. Another solution, though, another possible x value is x equals positive 2. Because if I sub in x equals positive 2, I'm going to get 2 minus 4 times 2 minus 2 equals negative 2 times 0, which is 0. So there are two values of x that we can sub into this equation that are going to make that left-hand side equal right-hand side, or are going to satisfy the equation. The same is true for this second quadratic equation that we have over here on the right. We could, if we wanted to, expand and simplify to get x squared minus x minus 6 equals 0. But when we have it like this, it's easier to see what those values of x are that we can sub in that is going to make it possible for this to be 0. So we can see that one value would be x equals positive 3, because if we sub that in here, that first bracket is going to equal 0. The other value is x equals negative 2, because if we sub negative 2 into this bracket, we get negative 2 plus 2, which is going to be 0, and then 0 times anything is always going to be 0. So one thing that we want to notice about this is that when we have quadratic equations, we can have two solutions. Now, they don't have to have two solutions. They can actually have two solutions, or one solution, or 0 solutions. Okay? But they can have up to two solutions. So if we look at one of those linear equations that we just solved, 2x minus 4 is equal to 0, and I plot the graph of a function that is y equals 2x minus 4, we can see a connection between the solution, like our solution here was x equals 2, because 2 times 2 gives me 4 minus 4 equals 0, and the graph over here, well, if x is equal to 2, and we find x equals to 2 on our graph, x equals 2 is right there. Okay? This point, which is our solution to the equation, is the x-intercept of the graph. We see the same relationship when we look at quadratic equations. So we solved this quadratic equation just on the previous page. Our solutions were x equals positive 3 and x equals negative 2. And when we look at the graph of y equals x minus 3, x plus 2, we see that, again, these two solutions here, x plus 3 and x equals negative 2, are the x-intercepts of our graph. So we said earlier in the course that a parabola can have two x-intercepts, it can have one x-intercept, it can have no x-intercepts. In the same way, it can have a quadratic equation can have two solutions, one solution, or no solutions. Okay, so this is all kind of background here. What do you need to be able to do? So you need to be able to solve a quadratic equation by factoring. A quadratic equation looks like this: x squared minus 8x plus 12 equals 0. And we always want to have this arranged so that all of the terms are on the left side and it's just equal to 0 on the right side. And to solve these things, we are always making use of what is called the zero product property. And that is the fact that if we take something and we multiply it by 0, we're going to end up with 0. So a times b is equal to 0, then if either a is equal to 0 or b is equal to 0. So we want to get our quadratic equations into this form where they are written as something times something else. This is our factored form. And then whatever makes one of the factors equal to 0 is going to be a solution to our equation. So how does this work in practice? Well, let's say we've got x squared minus 8x plus 12 equals 0. We want to write our equation as something times something equals 0. Our first step is definitely we are going to factor this. And we know how to factor something like this. We are looking for two numbers here. This is a simple trinomial. We're looking for two numbers that multiply to give us positive 12, add to give us negative 8. Those two numbers are going to be negative 2 and negative 6. When we're factoring this, we know we're going to have two terms like this. We need the first term in each one has to be an x to get the x squared at the beginning, and then we're going to put our two numbers into the brackets as well. Now this is an equation, so this whole thing is still equal to 0. Now, how do I go from this factored form to our solutions? Well, we can take each one of these terms and figure out, okay, what is going to make that term equal 0? X minus 2 equals 0. Well, we know the answer there is x equals positive 2. So there's one of our solutions. And then we look at the other term, x minus 6. What is going to make x minus 6 equal to 0? Well, if I just add 6 to both sides, x equals positive 6. And those are our two solutions, x equals 2 and x equals 6. And if I want, I can check these by subbing those x values back into the original equation. I can go, my left side is equal to, 2 squared minus 8 times 2 plus 12. That gets me 4 minus 16 plus 12, which is 0. My right side is equal to 0. Okay. I can do the same thing for 6. My left side will be 6 squared minus 8 times 6 plus 12. Again, my right side is 0. So 36 minus 48 plus 12. Plugging this into my calculator, my left-hand side is equal to 0. So the meaning of these solutions is the same as it's always been. The values of x that are going to make the left side equal to the right side, it's just in a lot of these cases with these quadratics, we have two values that are going to make that happen. So let's practice a little bit here. I've got a quadratic equation here, 4x squared minus 12x is equal to 0, and I want to solve this. Now, this one, we know it's quadratic because the highest power on x is x squared. This isn't trinomial, but we still want to solve it by factoring. It's still set up so that we've got a bunch of stuff on the left-hand side is equal to 0. So let's factor. And the first kind of factoring we learned was common factoring. So let's see, what is common to these two terms? We can factor out a 4, because both 4 and 12 are divisible by 4. We can factor it in an x, because x is common to those two terms. Inside the brackets, we're going to have an x here, and we're going to have a 3 here, and this whole thing is still equal to 0. So we've got our two terms, one term here and one term here. We want to see what is going to make each of these terms equal to 0. Well, if x minus 3 is equal to 0, x has to equal positive 3. If 4x is going to be equal to 0, divide both sides by 4, x has to equal 0. So those are our two solutions, x equals 0 and x equals positive 3. Our next one over here, we've got x squared minus 21 equals 0. If we're going to factor this, we could first check to see if there's any common factoring. There is not. Then we could recognize that this is a difference of squares. X squared is x squared. 121 is 11 squared. Or if we didn't see this as a difference of squares, remember we can always put in that 0x term and factor this as a trinomial. So if we're doing this as a trinomial, we need two numbers that are going to multiply to give us negative 121, add to give us 0. Those two numbers are going to be 11 and negative 11. So we're going to have our two factors, x and x, to give us the x squared, plus 11 minus 11 equals 0. And then what is going to make each of these factors, or each of these terms, equal to 0? X equals negative 11. Negative 11 plus 11 is 0. And over here, x equals positive 11. Because positive 11 minus 11, it's going to give me 0. So we're really just doing the same factoring that we've done before, but we have this extra step here at the end where we're going to solve for x. So here we've got one, 3x squared plus 8x plus 4 is equal to 0. This one, what kind of factoring do we have to do here? Well, this isn't a simple trinomial because we have this value of um, a equals 3 here. So we're going to have to use our AC method. A times c is 3 times 4, 12. So we're looking for two numbers that multiply to 12 and add to our middle term is positive 8. I should say add to positive 8. And what are those two numbers that multiply to positive 12 and add to positive 8? Positive 2 and positive 6. So let's use those two terms, those two numbers, to break up that middle term. Plus 2x plus 6x plus 4 equals 0. Now we can take this and we can factor by grouping. What's common to our first two terms? The x is common, so we'll have 3x plus 2. What's common to our next two terms? 2 is common, x plus 2, and this is all still equal to 0. Oh, sorry, I forgot my 3. It's got to be a 3x plus 2. Because 2 times 3x gives me 6x, 2 times 2 gives me 4. Okay, now we can see that our 3x plus 2 is common to those two terms, so we can factor out 3x plus 2. And we're left with the x plus 2 is equal to 0. All right, what are our solutions? Well, our solutions are whatever is going to make these two factors equal to 0. This one here is pretty easy. I can see just by looking at it that if x is equal to negative 2, that factor is going to equal to 0. This one here, I might have to do a little bit more work. I might have to say 3x plus 2 is equal to 0, and then solve that little linear equation by bringing the 2 over to the other side. 3x equals negative 2, and dividing by 3. X equals negative 2 divided by 3. Those are my two solutions. All right. We'll do one or two more here, just to make sure you get the hang of it. I got 9x squared minus 6x plus 1 equals 0. Again, I cannot common factor this. There's nothing common to all three of these terms. It's not a simple trinomial because of this. A is 9, so we're going to use our AC method again. A times C is 9 times 1, which is 9. So I'm looking for two numbers that multiply to give me positive 9 and add to give me that middle term, 6. Those two numbers are going to be negative 3 and negative 3. It's got to be a negative 6. So we'll use negative 3 and negative 3 to break up that middle term. Negative 3x minus 3x plus 1 equals 0. And I wrote this equal sign at the beginning. I'm going to get rid of it because I've got that equal sign at the end equals 0. So this is just going to be 9x squared there without that equal sign. All right, and then I can factor this by grouping. 1 and 2, my two groups. What is common to my first two terms? 3 and x, leaving me with a 3x minus 1. And what is common to my next two terms? Well, I know that I want to get 3x minus 1. I see a negative 3x plus 1, so I'm going to factor out a negative 1, leaving me with 3x minus 1 equals 0. The 3x minus 1 is common to both terms, so I'm going to pull that out front, and I'm left with the 3x minus 1 equals 0. So my solutions now are going to be whatever makes each of these terms equal to 0. So if I look at my first term, 3x minus 1 equals 0, I can bring the 1 over to the other side. I know that x has to be 1/3. Now, the second term, 3x minus 1, is the same as the first term. Like this is actually, I could, if I wanted to, have written this as 3x minus 1 squared equals 0. So there's no point in taking the second term and figuring out what the x value is going to be, because it's going to be exactly the same as the x value we get from the first term. So this one, I'm just going to leave it as x equals -3 is my one solution. So we said earlier we could have two solutions, we could have one solution. This is a case where we only have one solution. All right. I think I'm going to skip over this page here, and we're just going to go right to the very end here. So here I've got a quadratic equation. Nope, I'm going to go back, and we're actually going to do these ones. So here I've got here I've got x squared plus 3x equals -2. Okay. In order to solve a quadratic equation like this, all of the ones that we've been doing up until now have been written as in this form: something times something equals 0. This quadratic equation is not in that form, something on the left side equal to 0. So before we do anything towards trying to solve this, we're going to rewrite this by moving that -2 to the other side. We're going to add 2 to both sides to get x squared plus 3x plus 2 equals 0. Now we can go ahead and factor this as a trinomial. Okay, we have our a is equal to 1. We're looking for two numbers that multiply to +2, add to +3. Those numbers are going to be 1 and 2, both positive. So when we factor this, we'll have our two brackets, x and x, 1 and 2, positive and positive equals 0. And by looking at those two brackets, we can see that our solutions are going to be x equals -2 and x equals -1. One from each of those terms. Okay, same kind of thing with this second one over here on the right. We've got 3x squared equals 6x. We want to first rearrange this so it's in a term, so it's got a bunch of things on the left-hand side equal to 0. So I'm going to subtract 6x from both sides to get 3x squared minus 6x equals 0. First, we're going to check to see if we can common factor. There's a 3 that is common to both of these terms, and an x that is common to both of these terms. If I factor out that 3x, I'm left with x minus 2 inside the brackets, and this shows us our solutions. We're going to have one solution, x equals +2, and from this term, our solution is going to be x equals 0, because 3x is going to equal 0 when x equals 0. All right, our last one finally here. If I have an equation like 4x squared minus 24x plus 32 equals 0, this is a complicated one to solve. I could do it by, let's see, I would have to common factor, and then I could factor the trinomial. But over on the right-hand side, I'm given a graph of 4x squared minus 24x plus 32 equals y. I can just read off these solutions from the graph. I remember that the solutions to my equation are the same as the x-intercepts in the graph here. So I know that my solutions here are going to be x equals +2 and x equals +4. If I wanted to check this, I could go ahead and do all of the factoring, or if I want, or I could check it just by subbing in these numbers into this equation, doing a left side, right side check. So let's just check one of these solutions by subbing, let's do x equals 2 into our left side. And we know that our right side should be 0. So 2 squared is 4 times 4 is 16 minus 48 plus 32. Putting this into my calculator, I get 0. So we got our solution just by reading them off the graph. We can always check by substitution, or we could have gone ahead and done the factoring.